Okay, let's do it. Halloween class. Um, okay, so I'm going to label this one 1, this one 2, um, and you know, uh, in the end, all the answers will be the same, but things will look different if you, as you go, if you label them different. And I'll call this A, B, and C. 1,000 kilograms. Good Lord. So it's 0.2 meters. So, well, I mean, this thing is just a wedge shape that goes way, way back into the page, is what that means. Um, we're we're doing this as a planar problem, but uh, if the thing is prismatic all the way going back into the page, there's nothing saying that to treat it like a plane, it has to be narrow in the dimension that we're ignoring. So, okay, free body diagram of body 1. Um, so we have something like this, and there's a force vector RA there, and a force vector F on 1 by 2 there. And then there is a weight force that's equal to 9810. And we have to figure out where that location is. So you can think of this as 2 right triangles. And if both of those have the same centroid, then the whole thing has that same centroid. Uh, you could actually prove that using the sum formula. That'd be a good question, actually. I should. Um, so, okay, that means that we know that the centroid, it's got to be on that axis of symmetry, and this distance is like 2 times the length over 3. The total length of that is 0.4. So 0.4 over 3 is 0.13 repeating. Yep. And then this would be 0.06 repeating. No. 4. Oh, 4. Oh, right. 4. So this should be, that's wrong. So 8/3. So 0.26 repeating, and this should be 0.13 repeating. And now they add up to 0.4. So, okay, that's better. And then the area of this thing is, so one, here, let me just read some news for a second. Let's see. So the area is the base of, what's the height of that? 0.2 times 0.4 over 2. So 0.04. We don't actually, that's not going to come into the calculation. God dang it. Go away. All right. So this distance here is 0.26 repeating. And now I'll go to the table. So rho, force, moment. I'll put my about point here. So my force RA has a rho vector of 0, a force vector of RAX, RAY, cross product of 0. Then my F12, I did get all the forces right, yes. F12, the rho vector is 0.20. The force is F12x, F12y. Cross product is 0.2 F12y. And then the weight force, that rho vector is 0.26 repeating, 0. And the force vector is 0, negative 9810. So the cross product is negative 2616. And so my first three equations, I have RAX plus F12x plus 0 is equal to 0. The second equation says RAY plus F12y minus 9810 is equal to 0. So I'll move that over to the other side. And then the third equation says 0.2 F12y minus 2616 is equal to 0. So this is equal to positive 2616. Yep.
Why the force 1 into is not the same to the weight, like 0.26, and the other one is only 0.
Well, it gives you the dimensions of where that joint is. So that joint is only 0.2 from the end.
Oh, okay.
But the where the weight acts depends on the centroid.
Oh, okay. All right.
And then we'll go to the second one. So free body diagram of body 2. So this is vertical. We have, this has a mass of 250. So that weight is 2, 4, 5, 2.5. And that's just a rectangle, so it's at the center. Then we have a horizontal force of 6,000. Up here we have the force on 2 by 1, which is negative F12. And here, this is a pin, so that's an unknown force vector, RC. I'll put my about point down here for this. Remember, you can move your about point for each body. For each body, it needs to be consistent through the body, but when you go to the next body, you can move it. You do have to keep the same coordinate system directions. That's the only thing you have to keep. Okay. Otherwise, it changes the meanings of the variables, is why you have to keep the same coordinate system. Okay, RC, rho vector is 0. Force is RCX, RCY. Cross product is 0. Then there's the weight. This thing has a height of 0.5. So from the about point, the row vector is 0.5. Oh, sorry, the whole thing is 0.5, so this is at the midpoint. Yep. So 0.25. The force is 0, negative 24, 52.5. Cross product is 0. Then the 6,000 acts at the same point as the weight, so it has the same row vector. That force is negative 6,000, 0. And so the cross product is 1,500. And then last is the force negative F12. That row vector is 0.5. The force is negative F12x, negative F12y. The cross product is positive 0.5 F12x. And so my equation 4 says RCX minus F12x is equal to positive 6,000. Equation 5 says RCY minus F12y is equal to positive 2452.5. And equation 6 says 0.5 F12x is equal to negative 1,500. We have 6 equations, so hopefully we have 6 variables. Our variables are RA, that's a vector, so that's 2 variables, F12, and RC. So 6 equations for 6 variables. So my augmented matrix needs to have 7 columns and 6 rows. So these are equations 1, 2, 3, 4, 5, 6, and variables RAX, RAY, F12X, F12Y, RCX, RCY, and then the constants. Okay, so equation 1, RAX and F12X, we have 1. Equation 2, the y components of those same things have components of 1, have coefficients of 1, and then 9810 is the constant. So 1, 1, 9810. Equation 3, F12y has 0.2. F12y has 0.2. And then the constant was 2616. Then equation 4, RCX has 1. F12x has negative 1. Constant is 6,000. Equation 5, RCY has negative 1. Nope, positive 1. F12y has negative 1. And the constant is 2452.5. And then F12x has 0.5. and the constant is negative 1500. So I got RA vector is equal to 3000 negative 3270 F12 is negative 3000 13,080 and RC is 3,000 15,532.5. Anyone get that? Okay. So let's do what we're really using this for is always to calculate external loads on those bodies. So let's plug these back into the free body diagrams and see what the bodies look like, you know. So free body diagram of 1. We have a force vector over here of 3,000 negative 3270 and a force vector here of negative 3,000 13,080 and then a weight force here of 9810 and then free body diagram of body 2. We have a weight force of 2452.5, an external force of 6,000, a force up here. This is negative F12, so this is positive 3,000, negative 13,080. And then RC is 3,000, 15,532.5. When we get into deform, we'll be using external loads on bodies like this to calculate stresses and strains. And so these are the forces that you would use then to calculate the stresses and strains in that body. Or if you ever use a finite element modeling program, these are the forces you would plug into the finite elements to come up with the stresses. Any questions about that? Okay, let's get into another example problem, and I'm going to just stop at each step and let you try to do the step, and then I'll do it. Just make sure you're thinking about stuff right. So let's say we have a triangle. With a roller at the left side and a pin at the right side. This roller is connected to the body by a pin, and then these are connected to each other by a pin. And then a cable connecting it to the wall. And let's say each one of these angles is 80 degrees. And the lengths of each member will make it 2 meters. And the mass of each member is 20 kilograms. And we want to calculate the external loads on each body. I guess on is better than in. I'm going to number it like this. I'll call this body 1. I usually just do it sort of from left to right, but there's no reason you have to do it that way. I'll call this joint A, B, and C. And we'll start with a free body diagram of member 1. So take a few minutes. Feel free to talk to each other about it. Ask me questions if you get stuck or whatever. But see if you can draw this free body diagram of member 1. Okay? All right. So we're going to treat that pin as part of member 1 since that's the lowest numbered member at that joint. So I guess I'll put the weight in first. We have a weight of 196.2 newtons. And up here, since the pin is part of member 1, touching that pin is member 2. So there's a force vector F12. And also touching member 1 is the cable because that's touching the pin. So I'll call this T. And then down at the joint A, all we have is a roller. So the rule for a roller is perpendicular to the surface toward the chosen body. So I'll call that RA. And now for doing the table and stuff, you can choose whatever about point you want, but let's all do it the same just so our numbers look the same. Let's put our about point here, okay? And take a couple minutes and fill out that table. Okay, so row, force, moment. Oh, by the way, I've seen some stuff in weekly assignment. I guess I just graded a weekly assignment finally. And there were some people filling out the table like this, like my solutions do, which is perfectly fine. You know, the way that works is you come up with the coordinates for where the force is applied, the coordinates for the about point, subtract them, and it gives you a row. So if anyone's wondering why the solutions have a form like this, and in class I do it kind of differently, I just don't really do it any more like that, and I just haven't updated the solutions yet. Both ways work perfectly fine, but whoops. Okay, so I'll start with RA. That's at the about point, so row vector is 0. The force is 0 RA. Cross product is 0. Then the weight, the row vector is 0.174, 0.985. Force vector is 0, negative 196.2. Cross product is negative 34.14. Then F12. The row vector is 0.347, 1.970. Force vector is F12x, F12y. Cross product is 0.347 F12Y minus 1.97 F12X. And then the last thing is that cable force T. That's the same row vector, same location as F12, so 0.347, 1.97. The force is T0, so the cross product is negative 1.97 T. Anybody have any questions about any of those calculations?
Where is located the weight?
It's at the midpoint of that, so you can do that. Since this thing has a length of 2, and this angle is 80 degrees, you can do that as just 1 times cosine and sine of 80.
Okay.
And then the other thing you can do is you could do these first, figure out the, the row vector for that. And remember that the row vector for the midpoint is just the average of 2 things. So then you could average, basically, since this has a row vector of 0, then you could just take half of that and it would be that. Okay, so the first 3 equations, the first one says F12x plus T is equal to 0. The second one says RA plus F12y is equal to positive 196.2. And then the third one says negative 1.97 F12x plus 0.347 F12y minus 1.97 T is equal to positive 34.14. Okay, and then we'll go to the second body. Take a couple minutes and see if you can do that free. Okay, so this one, we have the weight at the middle. That's 196.2. Up at the top, now the pin is part of member 1. So the cable is not attached to body 2. It's not contacting body 2. The only thing touching body 2 is the pin. Okay, and so that is the force on 2 by 1, since the pin is 1. And to get the lowest number of variables possible, I'll write this as negative F12. And that's it up at the top. Okay. And then down at the bottom, this is a pin joint. So I'll call this RC. Okay, now take a couple minutes and write out the table for that. Let's put the about point here for this one. Okay, so row, force, moment. So I'll start with RC. Row vector is 0. Force vector is RCX, RCY. Cross product is 0. Then the weight force, the row vector is negative 0.174, positive 0.985. Force vector is negative 0, negative 196.2. Cross product is positive 34.14. And then negative F12, row vector is 0.347, 1.97. Force vector is negative F12x, negative F12y. Cross product is negative 0.347 F12y plus 1.97 F12x.
0.347 be negative.
Yep, thank you. And that makes this also negative. No, it doesn't. It makes them both positive. Okay, and then so equation 4 says RCX minus F12X is equal to 0. Equation 5 says RCY minus F12Y is equal to positive 196.2. Equation 6 says 1.97 F12X plus 0.347 F12Y is equal to negative 34.14. Again, this is 6 equations for 6 variables. So we have 7 columns, 6 rows. The variables are RA. I'll do T next, and then F12X, F12Y, and then RCX, RCY, and then the constants. Equation 1, F12X and T are both 1. Equation 2, this should say RAY. No, there's only RA. So RA plus F12Y. So RA is 1, F12Y is 1, and the constant is positive 196.2. Then equation 3, F12X is negative 1.97. F12Y is 0.347. T is negative 1.97. And the constant is 34.14. Then equation 4, RCX is 1. F12X is negative 1. Equation 5, RCY is 1. F12Y is negative 1. And the constant is 196.2. Equation 6, F12X is 1.97. F12Y is 0.347. And the constant is negative 34.14. Okay, and now